Hey folks, welcome to a new video. So in this video I wanted to discuss about a mistake. It's not a it won't be a good thing to call it a mistake. Let's say a bad habit that people who have been using React for a long time develop without even realizing what they're doing, right? So it's sort of setting the stage for a topic that we will discuss for a while. It's about immutability and mutability, right? So understanding understanding mutations and the things that you can mutate or the things that you can modify, or when new things are getting created, right? So that's very essential to understand when you are doing JavaScript. But I mentioned React develops this very bad habit of not using mutations at all. If you have been doing React for a longer time, probably you also have it, which is useful when you are using React because the way it's made because React uses shallow comparison to re-render stuff and decide like when to render, what to render, when to refresh the view and what not, right? So when you are using that kind of comparison, mutating an element might not re-render the page or might not perform the action, might not lead to the consequence that you are expecting by doing some action. But when you move out of the React ecosystem, this becomes a problem, because if you are writing, let's say, Node.js or any JavaScript that's running anywhere else, and if you follow that norm, you don't have that constraint to make everything like you don't have that constraint to not mutate anything outside React. Inside React, like, there is this constraint for many cases which leads to this habit, but outside React you don't have this. But since you've been working for React for such a longer duration of time, you sort of get the muscle memory of doing this. I'm not saying purposefully, by mistake, which can lead to a lot of issues. So we'll mostly discuss about that in this video. I'll just in the current video I'll mostly set a preface of what we'll be discussing about, maybe one or two more videos because it's a longer topic and it will take a while to cover. But I'll just set the stage for what we are going to discuss. So let's say we have this, right? Let ARR equals to 1, 2, let ARR equals to 1, 2 and 3. Then we have a loop for let I equals to 0, I less than, let's say, 100,000. Is it 100,000? Oh no, 10,000. And let's do I plus plus. Oh, sorry. I plus plus. Then what we have is now let's say I want to append 1 to this array 1,000 times. So I do this, right? I do dot 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 ARR and I do 1. And just to verify it, let's do console.log I dot length, maybe. I cannot print the whole thing. Oh, if I can spell it properly, length. Okay. So now let's try running this. If you feel there is something wrong here, I mean, just hold on to it. Just look at the code for a while and see what can go wrong here. What are we doing a way that it shouldn't be done? Our main goal is to change the original array to append one, like append an element 100,000 number of times, but we are doing something wrong here. So if you are not able to identify it, we'll have a look. We'll have a look at the data and the resources that it consumes, and then you'll have a better understanding of it. So let's try running it and let's wait for it to happen. So you see instantly the memory spiked up, the CPU spiked up, and the CPU is at its peak, right? It's at 9800 and it's still not done. It's still running the whole thing. But you might think it's a very simple thing, right? We are not doing anything as such. We are just mutating, or no, sorry, we are just adding elements to a given array. But why is this mess happening? Or is there a better way to do it? So that's the question, right? So yeah, we'll come to that, but let it finish first. Let's see how long it takes. So the CPU is fried, memory consumption seem to be going up, and it's still not done yet. It's still running. So in the meantime, let me explain this. When you do this, what it does is it creates it creates a new array, right? It's not mutating the old array, it's creating a new array. So when you do this, you are creating an array 100,000 times because it's looping in for 100,000 times, and then you are like adding that element. So every single iteration you are going through the whole process of creating an array first, and then you are adding the element at the end. So it's sort of a O of n square operation, right? If you look at it properly, but it doesn't look like that from the first glance of it because you're not aware of what is this behind the scenes. If you were to create an array, how would you create it? For I equals to, some x, for I equals to 0, I less than arr.length, I plus plus, you put everything in an array. That's the way you create an array. So you can, whenever you see a destructuring operator like this, I can't even begin to comprehend how many times I've seen this. And when I ask the person who did this why you did this, the obvious answer, like the most of the time, the actual answer that I got was it looks good, rather than like old pushing elements and stuff, or maybe like they are not aware of doing things like that. They are just sort of, they have been using React for so long time that they are just sort of used to doing this only, destructuring and putting elements and all. So see, it's not done till now, it's still going on. So let's stop this, no point. So that's the problem. Now how do we fix this? Since we are going with destructuring operator, so just be careful while you are using destructuring. It may look fancy and stuff, but what you can imagine is behind the scene it's just a for loop. Since it's reinitializing your array again and again and again, it will take more memory, more CPU. And let's make it a bit smaller. I just want to make sure both the outputs are same when I demonstrate this and the other one. So even in this, okay, I is not defined. Huh? Oh, okay, sorry. ARR, and let's do this as 100,000. 100,000 might be a long. Let's do. Let's make it 5. Let's say now. I'm just looking for a number in the sweet spot somewhere in the middle where I can show it takes up CPU, but I can also show the output is correct. It doesn't seem to be the correct number. 500,000, maybe I should make it less. Let's try with 300,000. Run. The CPU spiked up. I hope it finishes running soon. Oh, oops. Yeah, it's done. So we get this as the output, right? So it's the length of it, or how many elements are there in the array after it's done after it's completed and stuff. And now let's do this. Now let's do the non-conventional, non-glorified thing of array.push. Array.push 1. Cool. Conventional, non-glorified way. Like it's the obvious, not the obvious, but the ideal or the thing that push is made for is something like this, handling operations like this, right? So let's do this and let's see what happens. It didn't even take like maybe 0.7 second or something, I'm not sure. But just compare these two things, right? You did the same thing, you got the same length. If I print the elements, those will be also same, but I just printed the length so that it's easy to demonstrate here. But if you are not aware of how what destructuring does behind the scenes, you could miss a lot of things up here, right? You could like do some certain operations. You can handle it in a way that your resources are like on spike, and you can pay the cloud bills as much as you want. So understanding these things are very important, especially like if you're in JavaScript in a backend or some non-React environment as such, because React gives this really bad habit of not getting used to mutations and initializing new things every single time. So yeah, we'll discuss more on this. We'll go through more examples. We'll understand where you should mutate, where you should not prefer mutations and stuff, and some problems with so-called immutable structures in JavaScript as well. We'll go through those. But yeah, I think that should be it for this video. I just wanted to set the stage for what we'll be discussing in next 3 to 4 videos as such. And it's very important to understand mutability and immutability, and how you can use those to your advantage, and how, if you are not aware of what you're doing, you might suffer as well, and your cloud bills will just, yeah, that's what. So yeah, that should be it for this video. See you guys. If you have any comments or if you have any questions, you can ask in the comments. If you like the video, share it with your friends. And yeah, see you guys. Bye.